Let's continue our discussion of digital circuits. So we talked last time about there's different kinds of logic gates, and, or, nor, all those sorts of things. And so they're sort of basic, we can do basic logic, but sometimes we want circuits that will remember the state even when you change the inputs, right? And this is really at the foundation of a computer and that kind of logic. And so the first digital memory circuit is the reset set flip-flop, or the RS flip-flop. So essentially, it's a chip. It has an input that's set, that's S, an input that's reset, that's R. It has an output Q, and it has an output Q bar. And typically, Q bar is the opposite of Q. And so the truth table looks like the following. If S is low and R is low, then the output, there's no change to the output. Whatever it was before, that's what it will stay doing. If the set is high and reset is low, then the output will be 1. The output bar will be 0. If set is 0 and R is 1, then the output is 0, Q bar is 1. Right? And it just turns out that 1, 1 is forbidden. We don't know what's going to happen. You don't get to use it. But you can sort of see the name. This allows you to sort of set what the output's going to be. I want it to be 1, or I want it to be 0, or I don't want to change it at all. Okay, but it remembers the output is either what you set it or reset it to, or there's no change, so it'll stay whatever it was until the conditions are right to change. Okay, so that's sort of the basic circuit. So we can now look at the JK flip-flop. And so you can see this is sort of the next level. We've got set and reset, which are the sort of similar to what we saw before, an output and an output opposite of the output, Q and Q bar. And then we also have these inputs J and K and C, which represents the clock. And so it does a few things. Some things are exactly the same as before. If set is 1 and R is 0, it doesn't matter what you have on JK and the clock, the output's going to be high. So I mean, this part is exactly the same as the flip-flop we saw before. If we have set 0 and reset 1, doesn't matter what JK and the clock are, the output's 0 and Q bar is 1. We're not allowed to put S and R high, the same as before. But now if we have the case where S and R are 0, okay, in all those cases, now it matters what's on J and K. If J is high and K is low, and the clock, and this arrow represents, goes from low to high, so on the transition from low to high, then Q will be 1 and Q bar will be 0. If there isn't, if it's low or it's high or it goes from high to low, then there's no change in the output. Or if we have J0, K1, and we see an up transition on the input, on the clock, then the output will be 0 and Q bar will be 1. Okay, so it's sort of a similar to the set and reset, only it sets when, like, you can send it a signal and say, now switch now when I change the clock from low to high. Now, this is probably where we use it the most. We can toggle JK. If J and K are both high, then when the clock goes up, when we go from low to high potential on the clock, then the output is the opposite of whatever it currently is. So if it was 1, it switches it to 0. If it was 0, it switches it to 1. So this Q minus 1 is it sets it to what it was before in the last cycle. Essentially, it toggles, it changes. If it was high, it goes low. If it was low, it goes high. And if J and K are both 0, then it doesn't matter what the clock does. There's no change. Okay, so that's the JK flip-flop. There are other kinds of chips. There's clocks. There's the 555 timer. You can put in a certain R and C value, and then you can get pulses of varying time. The up pulse and the down pulse can be different, and this is sort of a digital output, so it's 0. We can define the high time by the appropriate choice of R and C. We can define the low time by a different choice of R and C, and then the chip itself will just output this signal continually until you tell it you turn it off. Okay, so that's the 555 timer. We can get a series of shots, however, at whatever frequency we want. The other is the monostable one shot. This gives an output of fixed width on an up or down change. So it only does one. So if we have an up change, we go from 0 to 5 volts, it'll output a pulse of a certain width, right? You get to define that width by the choice of R and C, but it only does one of those pulses. And so this sort of, if you trigger it, it gives you a pulse. If you trigger it, it gives you a pulse, and you can have that pulse be whatever you want. Or you can do the opposite and have it be high and give you a notch of a certain width. And so those are some of the basic circuit elements in the digital world. And so we'll explore some of these in lab.